of foiling, which is what we worked on yesterday. We worked on foiling. Today we're going to work on factoring. Okay, so let's take a look at this. We're going to start off with just some quick bell work here. So FOIL each of these pair of binomials. Remember, FOIL means first, outside, inside, last, or you're basically distributing the j times the j, which is j squared. J times 7 is 7j. 5 times j is plus 5j, that's the inside term, and 5 times 7 is 35. We combine like terms as the terms in the middle, so we'd have j squared plus 12j plus 35. That's our final answer. We take a look at the second one. That would be 2b times 3b, which is 6b squared. 2b times negative 8 is negative 16b. Negative 6 times 3b is negative 18b. And negative 6 times negative 8 is a positive 48. We combine the middle terms. Let's see, we'd have 6b squared. Negative 16 and negative 18 is negative 34b. And then plus 48 at the very end. Okay, 4y times 5y, that gives us 20y squared. 4y times negative 2 is negative 8y. 1 times 5y is a positive 5y. And 1 times negative 2 is negative 2. We combine our middle terms. So we give us 20y squared minus 3y minus 2. Next, we'll take x times x. That's the first terms. That gives us x squared. X times negative 4 is negative 4x. 3 times x is positive 3x. And 3 times negative 4 is negative 12. We combine the middle terms. That's x squared minus x minus 12. A lot of students are tempted to put minus 1x. When you have just a 1, remember you don't need that coefficient out front, so just leave it as negative x. Last one, our first terms, that'd be 9x times x. That's 9x squared. 9x times negative 9 is negative 81x. Negative 2 times x is negative 2x, and negative 2 times negative 9 is a positive 18. We combine the like terms, the ones in the middle. That gives us 9x squared minus 83x plus 18. Put a box around that because we are done. This is a good warm-up from what we did yesterday. These are the skills that we learned in this previous lesson. To FOIL, you'll end up with 2 binomials multiplied by each other, which give you in the end a trinomial. We are going from and doing the exact opposite process that we call the inverse operation. We are going from this trinomial, and our goal is to be able to get some sort of binomials, 2 binomials back. So you start with a trinomial, you end with 2 binomials. It's basically the exact opposite process that we looked at today. There's many methods that teachers teach. I try to teach the X method. In the X method, what you're going to do is you draw basically a big X. Check that out. That's pretty sweet. And the idea with it is that you're going to end up taking this last number, the 12, you're going to put that up top. What you're going to put in the bottom is the 7. And what you're looking for is you're looking for 2 numbers that are going to multiply to give you 12 and add to give you 7. So I might think, well, 1 and 12 multiply to give me 12, but they don't add to 7. 2 and 6 multiply for 12, but they don't add to 7. But 3 and 4, they multiply to give me 12, and they add to give me 7. So here's how this works. I will basically have, if you can think of this as my x times x would give you my x squared. And then I would just put a plus 3 here and a plus 4 here. And if I was to FOIL this and combine the middle terms, this is exactly what I would get. So this is the exact process that we took. We took these 2 guys on the ends, and we just plunked them in here very easily. Let's try this next one. It's going to be G here and a G here, and we're going to use the X method. Remember, we put the 10 on the end, and we put the 7 at the bottom. They need to multiply to 10 and add to 7. So I think, well, 1 and 10, that doesn't work. But 2 and 5, 2 times 5 does give me 10, and 2 plus 5 gives me 7. So I say G plus 2. G plus 5. Let's keep going with this X method. We'll put the 20 up top, the 21 on the bottom. 20 times 1 multiplies to give me 20 and adds to give me 21. So I'll just say V plus 20 and v plus 1. Now, some people ask, what if they would have written, v plus 1 times v plus 20? Is that still okay? And that is okay. Yeah, both of these are exactly the same. They just have these two guys mixed around. It's totally okay if I write this entire set of parentheses first or second. As long as both of these are up here, we're doing fine. Okay, continue with this x method. We put 30 up top, 13 on the bottom. 1 and 30 doesn't work. 2 and 15 doesn't work. But how about 3 and 10? 3 times 10 does give me 30, and 3 plus 10 gives me 13. So I'll just say a plus 3 and a plus 10. Again, if you had a plus 10 and a plus 3, those would both be correct as well. Let's see. We have k. We're going to have a 25 here and a negative 10 on the bottom. That's going to be a little bit different. So you need to multiply to give me 25, but add to be negative 10. It means probably these numbers are going to be negative, I would think. So like a negative 5 times a negative 5 would give me a positive 25. When I add them together, it'll be negative 10. So I'll just say negative k, or k minus 5 and k minus 5. And here's another trick while I'm at it. Since those two are exactly the same, the best way to write this is k minus 5 squared. This is basically factoring and simplifying fully. That's what this part is the simplifying, if I can spell, simplifying fully. A lot of students will say, well, if I stop here, is that okay? Well, technically it's not simplified all the way. This step down here is simplified all the way. It's in the simplest form you can find. Let's try the x method here for number 6. We'll put the 18 up top, the negative 11 on the bottom. 1 and 18 don't work. 2 and 9 don't work. But what if 2 and 9 were negative? Negative 2 and negative 9. Remember, a negative times a negative does give me a positive, and a negative plus a negative gives me a negative down here. So that will work. So negative 2 and x minus 9. We're just moving right along. Hopefully you're taking good notes as we're going along here. I think that'll really help out in the end. Let's try this with the x method. Put the 36 up top, negative 15 on the bottom. Again, I'm thinking both these numbers are probably going to be negative because this is positive and this is negative. So let's see, negative 6 and negative 6 won't work. How about 9 and 4? That doesn't work. 12 and 3. So maybe negative 12 and negative 3. And all I'm doing is I'm just trying to list the factors of 36. So if you're not good at division, this can be kind of a difficult deal. So we'll have q minus 12 and q minus 3. Try the x method one more time here. Negative 27, positive 6. This time, notice this is negative and this guy's positive. This is a little bit different. What I think here is going to happen is there's going to be one number that's going to be negative, one number that's going to be positive, and the positive one's probably going to be the bigger number. So what I mean by that is if I have negative 9, if I have positive 9 and negative 3, those two numbers multiply to give me 27, negative 27, and they add together to give me 6. If I would have switched this around and had negative 9 and positive 3, that would have given me a negative 6. So you really got to watch the signs. This is really attention to detail type stuff here. So make sure you're paying attention. Let's see, negative 18, negative 3, they're both negative. So that means one's going to be negative, one's going to be positive. Let's see, I probably have like a negative 6 and a positive 3. Negative 6 times 3 does give me negative 18. And negative 6 plus 3 does give me negative 3. So I'll have p minus 6 and p plus 3. Some students say, hey, can I just what's the deal with all these weird variables and everything else? Your variables is just that. It's something that varies. It changes. We do see a lot of x's when we're dealing with Algebra 1 type stuff, but really any variable can be there. We can even see places where they use not even our own alphabet, they use the Greek alphabet, so watch out for that. In this case, this is a negative 1, so just keep that in mind. That means basically that these factors are going to be 1 apart. So I think, well, it's probably not going to be 1 and 56. It's not going to be 2 and 28. It's not going to be 3 and anything. It's probably going to be 7 and 8, because 7 times 8 does give me the 56. Since this is negative, I know that one of them has to be negative. And since this is a negative 1, I know this guy has to be negative, because I have to take negative 8 plus 7 to give me the negative 1. Remember, these two multiply to give you this one, add to give you this guy. So I'll just say y plus 7, y minus 8. Let's try this one. We have negative 20. We have positive 8 down here. Probably thinking going to be a positive 10 and negative 2. The idea with this is there's not many variables, there's not many factors of these, so it's really not that hard just to kind of go through them in your head. Let's try this guy over here, negative 40, and negative 3. So I think of all the factors of negative 40. That'd be 1 and 40. Well, that's not 3 apart. 2 and 20. That's not 3 apart. 4 and 10. That's not 3 apart. Let's see, maybe like 8 and 5. Oh, 8 and 5 are 3 apart. So I'm thinking 8. I'm thinking 5. Just listing the variables of 40. Since this is negative, one of these has to be negative. And since this number is negative, the bigger number has to be negative. Okay, because negative 8 plus 5 gives me the negative 3. So this would be r minus 8 and r plus 5. Whew, we're really making some headway here. Let's see, 3 more problems left. We have 15. We have 8. We're going to have an x here. We're going to have an x here. Let's see what happens. Factors of 15. Well, it's 1 and 15. 3 and 5. Oh, 3 and 5 work. So 3 times 5 gives me 15. 3 plus 5 gives me the 8. So that looks something like that. Over here, we have 20 up top, negative 9 on the bottom. Let's see, 20 is 1 and 20, 2 and 10, 4 and 5. So 4 times 5 does give me 20, but if both of these are negative, it also adds up to negative 19. So here we go, C minus 4, C minus 5. All right, last one here, X method, negative 48, positive 13. I'm looking for factors of 48. That's really tough. Maybe like 16 and 3. That's probably going to be a negative 3. So it multiplies to give me negative 48. Adds to be 13. This is x plus 16, x minus 3. This is a really powerful technique that's used all throughout mathematics. Really, we're building the foundations of sort of a calculus or a pre-calculus class. And this is the primary skill that's used in all of calculus and pre-calculus. It's really the idea that once you can figure out how to factor these concepts, you can figure out where the zeros are, which basically graphically means that's where the graph is going to cross over from being positive to negative. That has all sorts of applications in the economic world, the financial world, tons and tons of ways to talk about disease, to talk about all sorts of interesting concepts that calculus really was made to model. So the idea with calculus is it really models real-life situations, and we need this skill, this factoring skill, in order to help us. So in order to help you, I've gotten these 21 problems together. I want you to try to complete these on a separate sheet of paper. I want you to write out these problems, just write them out, show your work, probably using the X method or some other method that a teacher may have taught you in the past. Make sure to circle your final answer. So this guy, we just take and put a circle around that to show that this is what our answer is, and that's it. If you guys need help, make sure to let me know. Peace out!